Hey everyone, and welcome to The Explainer. Today we're tackling one of the most absolutely critical and potentially the most expensive technological crossroads your business is going to face, the machine learning acquisition dilemma. We're going to break down the choice between custom machine learning models and pre-built solutions. By the end of our time together today, you'll have a highly pragmatic playbook to help you navigate this complex landscape so you can confidently decide exactly where to invest your resources. All right, let's dive right in. Here's our roadmap for today. We'll start with the machine learning choice, look at the power of pre-built solutions, explore when custom makes sense, uncover hidden costs and data, walk through some practical business scenarios, and finally, wrap up with the smart hybrid strategy. So, starting off at section 1, the machine learning choice. Now, the stakes here are incredibly high. Getting this wrong, whether that's overbuilding a massive custom system or completely underinvesting, is a massively expensive mistake. So what should your business actually choose? We're essentially looking at a tug-of-war between highly accessible, ready-to-go solutions on one side and heavy, resource-intensive custom investments on the other. And the right choice ultimately depends on a few things: your data maturity, your budget, your timeline, and honestly just how much competitive differentiation that machine learning layer actually needs to deliver for your specific operations. Let's quickly define our terms here so we're all on the exact same page. Pre-built machine learning solutions are models that have already gone to school on massive general data sets. They're handed over to you as APIs or packaged software. Think of familiar tools like Google Vision API, AWS Rekognition, Azure Cognitive Services, OpenAI's language models, or Salesforce Einstein. The absolute beauty of these is that you just plug them in, configure a few basic parameters, and boom, you immediately get predictions. On the flip side, in stark contrast, we have custom machine learning models. These are models built entirely from scratch or fine-tuned specifically on your own proprietary data. And guys, this is an entirely different beast. Going custom requires serious infrastructure, rock-solid data pipelines, dedicated model training environments, complex validation frameworks, and endless ongoing maintenance. Literally none of that is trivial. And this brilliantly illustrates those exact trade-offs. If you look closely, pre-built decisively wins on time to deploy, getting you to production in days or maybe weeks instead of months, along with low upfront costs and low maintenance. But when we start talking about domain accuracy, strict data privacy, and explainability, well, that's exactly where custom shines. Your data stays strictly internal, and you gain fully controllable explainability. The core takeaway here is simple. Pre-built wins on speed and accessibility, while custom takes the crown for precision, control, and privacy. Moving right along to section 2, the power of pre-built solutions. So who are these pre-built tools actually made for? Well, if your business needs sentiment analysis, image classification, picking up on standard fraud detection patterns, language translation, or document parsing, these off-the-shelf tools are genuinely incredible. If your specific business problem fits neatly into one of these buckets, a pre-built solution gets you to production in days. But the trade-off, of course, is control. You're inherently working within someone else's assumptions, and the model was trained on general data that might not perfectly reflect your specific weird industry edge cases. Which brings us to section 3, when custom makes sense. Because there is a crucial tipping point where those super convenient pre-built solutions actually start to break down. First up, proprietary data. Imagine a logistics company that's been tracking 10 years of very specific delivery patterns across their routes. That data is a massive competitive edge that no general model has ever seen. Second, domain-specific use cases. Think medical imaging or agricultural yield forecasting, where everyday data signal patterns just totally fail. Third, regulatory demands. In finance or healthcare, you often legally cannot use a black box third-party model. You need to strictly audit exactly how a prediction was made. And finally, volume. Pre-built tools charge per call. When you're making millions of predictions a day, those API costs become absolutely prohibitive, and hosting your own custom model suddenly becomes the much cheaper path. But hey, the payoff for getting custom, right? It is huge. McKinsey actually reports productivity improvements of 20 to 30%. But, and this is a big but, that is only when the machine learning perfectly fits your actual business context. This really proves that while going custom is hard and incredibly resource-heavy, the ROI is massive when the model aligns flawlessly with your core business workflows. Just remember, that number drops off a cliff if the model doesn't fit the context perfectly. All right, section 4, hidden costs and data. Time for a quick reality check. $12.9 million. I just want you to let that number sink in for a second. According to Gartner, that is the estimated average annual cost of poor data quality to organizations. It's a pretty stark wake-up call for any business that's just rushing headfirst into a custom machine learning build. It really all boils down to this harsh reality. Bad data fed into a custom model just produces a confidently wrong model. And let's be honest, most businesses vastly overestimate their data readiness. Before you commit to a custom build, you have to take a step back and honestly assess if your data is actually clean, properly labeled, and truly representative. Dirty data will absolutely ruin an expensive custom build. In fact, a pre-built model with much broader training data often handles messy, real-world inputs way more gracefully than a custom model trained on a small, noisy, internal dataset. Section 5. Practical business scenarios. Let's ground this in some reality. Let's compare a couple scenarios directly. Say you just need CRM predictions, fast. Like you want to layer lead scoring into Microsoft Dynamics. In that case, pre-built integrations make perfect sense. Quick win. But if you're building a core product where machine learning is literally the main feature you are selling to your customers, you can't just bolt that arm later. You need custom architecture built by dedicated full-stack developers from day one, just so the model layer aligns perfectly with the application structure. Now, what about legacy ERP modernization? Those older, clunky environments usually require custom models because the data structures and business logic are just way too specific for a generic solution to ever handle. Conversely, if you just want to automate repetitive tasks, like classifying thousands of emails or processing standard documents, business automation solutions built on pre-built APIs will deliver 80% of the value for just 20% of the effort. Take that massive quick win every single time. Finally, Section 6, the smart hybrid strategy. The truth is, this isn't really a permanent versus battle at all. It's more of a progression. Think about this. $30,000 to $80,000, that is literally just the starting development cost for a focused custom model built by a small team. And robust production-grade systems, those can easily run into the hundreds of thousands annually. Compare that to pre-built API solutions that start out incredibly cheap, but then scale aggressively as your volume grows. Your strategy absolutely has to balance these financial realities over time. And that exact financial reality leads us right into the pragmatic playbook, a really actionable sequencing strategy. Step 1, validate the problem with a pre-built solution first. Prove that machine learning actually solves your problem before you spend heavily. Step 2, while you're doing that, build the internal habit of collecting clean, beautifully labeled data. Step 3, revisit custom models in 12 to 18 months once your data infrastructure is actually mature. This minimizes your risk today while perfectly preparing you for competitive advantage tomorrow. We're going to end on this one provocative question. What does a wrong prediction actually cost your business? Seriously, start by defining your problem precisely and calculating that exact cost. Because if a wrong prediction is cheap, you should absolutely lean into pre-built. But if getting it wrong is disastrous, you likely need a custom investment. Going through that specific exercise usually makes the decision way clearer than any framework ever could. Thank you so much for joining me on this explainer today. Keep learning, and I'll see you next time.